Hello friends, so my name is Kishan Gopal. Okay, so today we will discuss how to find out the alpha and omega of the rod. Okay, physics. Question number one: how we can find out the omega or alpha of the rod which is placed horizontally and it is hinged from a point O, and we have to calculate the alpha of this rod. This rod is free to rotate in a vertical plane. Okay, so this is free to rotate in vertical plane. So how we can calculate its alpha? Okay, so what is the question is find angular acceleration of the rod. Initially rod is placed horizontally. Okay, so to find out the alpha we first calculate the uh, torque of the rod. Okay, so how we can calculate the torque of the rod? Torque is equal to the I alpha. Okay, so force that is acting downward is the mg force that is acting at com of the rod, and length of the rod is L and its mass is m. So torque of the mg will be equal to the mg and multiplied by its perpendicular distance from the axis, that is L by 2. Okay, so torque is equal to mg multiplied by L by 2. Okay, now I, what is the I of the rod? So I should be taken about the point where it is hinged. Okay, so it is hinged at the one end of the rod, that's why its IB will be written as ml square by 3. Okay, multiplied by alpha. So if here we can cancel out the L. Okay, so what will be our alpha here? Alpha is equal to the 3g by 2L. Okay, so this will be our correct answer. It's the alpha of the rod at this point which is free to rotate in a vertical plane. Okay, second question, let's take a second question. What second question is asking to you? If rod is not horizontal, in that case how we will solve the question? Okay, second position is like this. Initially rod is hinged like this, and the angle that is making with the vertical is theta. If it is making an angle theta with the vertical, in that case how we can calculate the alpha of this rod at this instant? Okay, so we have to find out the alpha again here at this position. So again we will apply the same concept here also. We first will calculate the torque of this rod about the hinge point O. Okay, so torque, what we know that torque is equal to I alpha. Okay, torque is generated by the mg force, that is gravitational force acting downward. Okay, so in this case what will be the perpendicular distance of this force? If we extend the line of force of mg behind upper side, in that case the perpendicular length will be equal to this length x. Okay, so how we can calculate the x? We can calculate the x by taking the component of this length L by 2 and L by 2 sin theta. X will be the L by 2 sin theta because it is opposite side. So mg x is the torque of the mg must be equal to I alpha. So what is x here? X can be written L by 2 cos, not cos theta, it is sin theta. Okay, so x L by 2 sin of theta. Okay, what is I here? I should be taken about the point where it is hinged. Okay, so it is hinged from the one end. Okay, so we can write moment of inertia like this, ml square by 3. multiplied by alpha. Okay, mass will get cancelled out here. Okay, L and 1L will also get cancelled out. Now alpha can be written like this, 3g upon 2L. Okay, 3g upon 2L and this sin theta upper side है आपका, so 3g sin theta upon 2L will be your correct answer. So in this way we can calculate the alpha of any rod which is free to rotate in a vertical plane. Let's see how we can calculate the omega of the rod also. Okay, question may ask you to find out the angular velocity of the rod. Okay, so how we can calculate the angular velocity of the rod if it is free to rotate in a vertical plane? Okay, let's take another illustration. So in another illustration, initially rod was like this and we are just pushing it slightly so that it can rotate in a vertical plane. So question is asking to us that what will be its angular velocity if it has reached at point B. This is the initial position and this is the final position. So it will rotate like this and we have to find out the omega of this rod when it has reached at point B. So how we can calculate the omega of this rod? So we will not apply here the concept of torque, rather than we will apply here concept of energy conservation. Okay, so energy conservation, how we can apply the energy conservation? Because our COM is moving from this point to this point. Okay, so there will be loss of potential energy and it will be converted into the kinetic energy of the rod. Okay, so let's apply the energy conservation. Okay, energy conservation. Okay, so let's see how much COM has dropped from this point. Okay, so this length is L by 2 and second height is x, and x can be calculated by the L by 2, x is equal to the L by 2 cos theta. Okay, so x can be written as L by 2 cos theta. So drop in potential energy, here we can write here drop in potential energy must be equal to the what? Increase in kinetic energy of the rod, because it will gain speed due to the kinetic energy. Okay, so drop in potential energy is what here? Drop in potential energy is mg L by 2 plus x. Okay, L by 2 plus x. Increase in kinetic energy, we know the formula that it is equal to the half I omega square. Okay, I must be taken from the point where it is hinged. Okay, so let's write down the value of x here also, L by 2 plus x is equal to L by 2 cos theta. Okay, x equal to L by 2 cos theta. Now what will be the I here? I can be written as ml square by 3. We know it already. Okay, ml square by 3 multiplied by omega square. Okay, so now we can calculate the omega. Here m and m will get cancelled out. Okay, now you can take L by 2 outside. Okay, so g L by 2 1 plus cos theta must be equal to L square by 2 multiplied by 3 multiplied by omega square. Okay, so 2 will get cancelled out with the 2. Now you can write here omega as omega square is equal to under root of L will get cancelled out with L. Okay, so g, sorry, here omega square we can take root another side. Okay, so g multiplied by 1 cos theta divided by L, and this 3 will come this side, 3g 1 plus cos theta upon L will be our answer. So our final omega can be written as under root 3g bracket 1 plus cos theta upon L. So by the method of energy conservation we can get the omega. Here we should not apply the concept of torque, because with the concept of torque we should calculate the alpha of the rod. Okay, so we'll take another illustration after some time. Okay.